Okay, thank you. Is this working? Yeah, good, great. So good afternoon. Thank you all for being here. Thanking for actually keeping up all the way almost to the end of it. So that's congratulations to you all. You almost made it. But today we're going to be talking about code reviews. My name is Paco van Beckhoven. After working many years as a software consultant at many different companies, I decided to move to Switzerland, where I joined a company called Hexagon, where I now work at the Innovation Hub on a project called HXDR, which is a cool cloud-based platform that allows users to create and upload 3D models and do all kinds of things with it, which is mostly because they paid for me to travel here. The most important part is that I really like code quality. I really like developer experience, and that is why I'm here to talk about code reviews, as that is part of the whole story. Now, I want to start with a number, $316 billion, which was in 2013, according to research by Cambridge students, the estimated cost of finding and fixing bugs. Now, correct for inflation and you'll get a much bigger number, and that's the amount of money we sort of waste because we somehow didn't implement features correctly. Of course, it's not all on us, but a lot of money is lost on bugs. Now, what we also know is that the longer it takes to find or fix a bug, the more expensive it gets the later in the development cycle. And because, for example, if a bug makes its way all the way to production, well, you have to find it, fix it, you have to maybe redesign some parts, it takes you a lot more time. Now, what we're going to be focusing on is what we call the code reviews. And these take place approximately in the coding and testing phase. Now, what is a code review? And I think to me, so this is a sort of a nice definition. It was either ChatGPT or Wikipedia. I'm not entirely sure anymore, but to me, it consists of three important parts. I would say the first part, which is what we mentioned before, is about finding and fixing bugs, right? We want to prevent bugs making their way to staging, to QA, to production. We also can use code reviews as a way to learn and coach from each other, or learn from each other and coach each other in getting used to development practices of the company, or getting a junior started on whatever development practices that we use. And it's also about fostering co-ownership as well, by the way, so making everybody part of the solution. Now, and last but not least, code quality, which I gave a definition of its own. It's about making the code more maintainable, readable, efficient, in line with your company's conventions and all. So this sounds pretty good, right? Code reviews, great. Super enthusiastic. Yes, so I don't want to hear this. Now, of course, because there will be people who won't agree with me, and I will agree with them that there's always nuances to this. If you're heavily invested in parallel programming, maybe you're in a highly performant team, there's of course reasons to not do code reviews. But for this presentation, we're going to assume that you want to do code reviews. And the way we typically incorporate this in our development practices is through what we call pull requests or merge requests. So I want to do a quick show of hands. Who says it's pull request? And who says it's merge request? Okay, and that probably also are the GitLab users, because GitLab really forced the merge request term on us. I am also a GitLab user, so during this presentation, my coworkers forced me to use the term merge, which means I'm used to using merge request. I mean either, to me they're the same, so whenever I confuse them during this presentation, just ignore it, it's pull request for me. Now, to do these pull requests, we have tools. We have these amazing version control systems, and these version control systems help us in facilitate us in creating and reviewing pull requests. And they contain also useful integrations to help us with that, and some nice features on how to improve our review. So even though we have these amazing tools at our hands that help us write better or do better code reviews, we still run into problems often. And for example, we have the pull request that always, with the great description, which has an even better title, but it also changed 55 files in the project. So this is, of course, the worst thing you can encounter, or one of the bad things. Of course, it can always be worse. You have the great feedback that you receive from people, or the fact that nobody's actually responding to your requests to actually start reviewing. And I think last but not least is the curse of the small pull request, where a small pull request of about 10 lines changed. Now all of the sudden the whole team has an opinion and you have the longest discussions over the lines that you have. Whereas if it's 500 lines, somehow people can review it in 5 minutes and say it looks good to me. So these are problems we encounter with code reviews. And now, how do we address these issues? And I'm going to go over a couple of best practices and ways in how we can make our lives better when it comes to code reviews. And the first step is to create review-friendly pull requests. And for this, I'm going to assume that our changes are going to be concise, focused, and tested, because that's not in the scope of this presentation. We're going to be looking at the pull requests themselves first. So the first thing we need is a title. And a title should be self-explanatory, like a good commit message. So fix bug is a bad title. But if we add the right amount of context, we can actually get a nice title out there. But as said, it's like a commit message, so why not adhere to standards we use for commit messages, like conventional commits, which help us to formalize the way we write our pull request titles, and we can even add linting and make the build fail if somebody creates a weird title. Because usually these commit messages also make their way into the release notes or some way, and it's nice to have those consistently formatted. And it's also good to always add some sort of ticket reference in there as well. Usually your VCS tool makes it clickable, so you can easily go to your task manager. Now next up is a description. And there's all sorts of things you can put in there. So just some pointers. I think usually you should start with adding some context, which is like the extension of the title, maybe with some more background on the feature. And then you give a sort of an overview of what has changed, something what the user can expect. I made some changes on the database, and I did some bonus changes there. Of course, maybe that should be a separate pull request, but that's not the discussion right now. And one that I particularly like is the why. And with why, I mostly mean, why did you make certain changes, or why did you make certain decisions? When you make changes, you go through some process. You try some things, and you figure out that some things may or may not work. And this knowledge usually gets lost if you don't write it down. And if it hasn't been written down in other places, I think the pull request is a great place to write down any considerations you made, any things you tried, because it can also help the reviewer in trying to understand why you chose a certain solution. Then it's also nice to add some examples as well. And for front-end, this is easy, add some screenshots of whatever you build. But for back-end, you can also add examples. You can add example requests and responses so that people also know how to test it quite easily, which is quite helpful, and know how the response looks like. Or maybe if you only made changes in the database layer, just add an example query and the example results. Also quite useful for the person reviewing. Now the challenge is to keep it all concise and readable. And this is the only part in my presentation where I'm going to mention AI. ChatGPT would be great for this, to actually sort of make it a bit more to the point, and because nobody wants to read a big wall of text. We want to have some nice headers and sections in there. Now, another thing that can help you with this is using templates. I'm really a big fan of templates. Please use templates whenever you have the option in your tools, because it makes it easy for people to expect where to find which information, or they know where to find it. And you can add checklists. And the nice thing about this checklist is this is a great place for anything you didn't automate yet. So say you have some process, like maybe you need to manually add release notes to a ticket, which, I mean, automate it, please. But if you didn't, then add it to a nice checklist at the end. Or what I particularly like is, for example, making people conscious about the quality requirements they need to adhere to. Like, did you actually add tests? Did you do your work on figuring out if the exception scenarios are handled? This is nice to remind people, because they have to check the checkbox. And if they then didn't write tests, then to me it's always a great reminder to write, I need to do this. Now, having created our pull requests, we're going to be the first reviewer. We're going to look at our own pull requests. The reason why is that when we look at our code when our changes from a different perspective, we'll be able to spot things that we probably, while in the process of developing, would have missed. And I think some perfect examples of this are leftovers from previous solution attempts. Maybe you forgot, you made some changes in a file, and then it turns out that there's this one file that still has a line break change in there. This is a great opportunity to undo this, to reduce the noise and make your pull request smaller. Or maybe there were some names, maybe there are some typos in your commits, so you figured out, hey, this wasn't tested right, I need to add this test. I usually find quite some things when reviewing my own pull requests that saves time to the reviewers, because they don't have to be bothered by it and they don't get distracted by them. And what also can be helpful is you can use you should also start with adding comments to your own pull requests. For example, if you want to add some context. Like in this example here, I deleted a file. While programming, I noticed that, hey, oh, this file is unused. Is it really unused? Since when is it unused? I did that research. I spent time on it. Document it so that the reviewer also doesn't have to go through this process. And also, maybe you want to add some hints like, hey, this here, I made a bug fix in a big file, and it turns out that my previous colleague didn't format the file. Now, I really like to format things, so I formatted the file. But now I get a bit of noise in my pull request because there's 20 lines change, even though my bug fix might only be a single line. And then you can, aside from the fact that this probably should have been 2 commits or separate pull requests, you can still highlight the important change. And it helps the reviewer in figuring out what's going on. Or maybe some extras, you got sidetracked. Add some notes to it. And you can ask specific questions here as well, like, hey, I'm not sure about this part yet. What do you guys think? Or, hey, this team, I'm integrating with you through this piece of code. What do you think about it? Now, having reviewed our own code, now we can get people to actually start looking at our code, which usually also doesn't go as desired. We create a pull request, but then people are not really reviewing it. And this can be for various reasons. People just simply don't like to get distracted because it usually is context switching, or they think they can't find anything, or they think it doesn't contribute to their work, which is, of course, all bad reasons. So ideally, we would round robin assign pull requests people to be proactive in this, but there's a different way. So the problem usually with these messages like this one is they're thrown into a channel that has about 20, maybe 10 to maybe 30 people in it. And then, especially when it's something that people don't really like to do, everybody will think that somebody else will do it, which to me usually is shared responsibility means no responsibility. So what helps is to target and tag specific people. Address somebody who you think has some experience in this area. And maybe you can just randomly assign it to somebody with mentioning them on Slack or anything. Because if you tag the wrong person, you'll see that they now all of a sudden can reply very quickly and telling you, oh no, you should be at that person. Which already helps in getting the review process speed up. What also helps is to add a bit of context. Don't just dump a link there, but add a bit of context what it's about. Because the people that might be working in a similar area think like, hey, this is interesting to me, I should have a look at this. And maybe add some deadline or some sense of urgency. Is this really urgent? Do people need to drop their work right now? Or can they do it at the end of the week so that they can sort of schedule the review for themselves? A message like this is more likely to get traction than the one above. And the thing is that this actually goes further than asking for pull requests. I would say this goes for if you need something from another team or another person, then rather than throwing a message in a channel with many people, try to target specific people, and the chance of it being picked up are much higher. Now that we get people to review, we can have to sort of deal with their feedback, which is not always as awesome as you hope it would be. And that could be various reasons. Some people simply lack social skills, and maybe this is the place where you sort of in a one-on-one tell them, hey, the way the way you format your messages, it's kind of, it might trigger people. But there might also be cultural differences at play. So I'm from the Netherlands. We're known to be quite direct, which some people might see as offensive even at sometimes, or they might get offended. So that's good for me to know that I should either fluff up my messages a bit and make them sound a bit nicer, or for others to know that, okay, he doesn't mean it like this. Now, the other thing that you come into are these endless discussions, right? If you have multiple people with strong opinions in the team, then there might be a fight, and this fight might be about spaces and tabs. I hope it's not about that, but it might also be about a solution, and both are convinced that they are right. Now, rather than having a 20-comment discussion in a pull request, which usually is asynchronous and takes a whole day and means that people are constantly getting out of their context, that's wasteful. So rather than that, try to take it offline or online, but in a separate synchronous meeting. Have a discussion. And then the most important part is to actually report back on this, the last thing. Because if you don't, then you sort of have this pull request, and then you look back at the discussion, and nobody actually knows what was decided because it was taken offline. Which, by the way, goes further than just pull requests. Again, this also applies to any messaging you have. You have a long discussion on Slack. You get into a meeting, and then you quickly report back in a Slack message, hey, we discussed this and we decided this because of this. And your future you will be very grateful for that, but also other colleagues who are sort of following around from the sideline, who now have a chance to also have an opinion. But luckily, it's not all bad. there will also be lots of useful feedback, things you missed, things you didn't know about, you learn new things, and then it might be helpful to also show some appreciation there, because it's like code reviews are not necessarily the most positive place. Show some gratefulness, because a positive message goes a long way. It might help people to be more confident. Maybe there's a junior that just started reviewing its first pull request and he finally found one thing. And being thankful for that might encourage him to do more reviews and or be more confident about it. So show more than just fixed. Doesn't have to be everywhere, of course, but show some appreciation. Now we've covered the side of what we can do as the person who created the pull request. We can now switch to the reviewer seat. Giving reviews, which is some nice chance for water. Yeah, so it's important to not wait too long with reviewing, because the longer you wait, the more chance you have on merge conflicts, the more context switching that takes place. Because if you ask for a review, then usually it takes half a day, maybe a day, for people to finally respond, and then you're not going to wait a day. So you're going to do some other things, and you're going to go back and forth. That's quite annoying. So what I usually tell people or give them as a suggestion is start your day with reviews. Because when you start the day, you're still fresh, so you don't have to switch context, because you may have no context yet. So this is a great chance to start reviewing, and or whenever you pick up a new task. Because whatever task you're going to pick up, given that your backlog is prioritized, will have a lower priority than whatever task has been picked up before. Which means that you should first make sure that the task that has been picked up before gets reviewed. Now, the other thing that's really important is that a code review is also about taking responsibility. I've seen it so many times that people just see it as a way to unblock people and just click the approve button, but I think it should be like a sign-off. Because in the end, you should also be responsible. And if you make people responsible, make them aware that they're now also responsible, they are now responsible for whatever they approved, then they might actually put some more effort into it. And I think that's the mindset we should all have, is that whenever we review something and approve something, we become a co-owner of the change. Now, when we start reviewing, we need to start getting some context first, right? We just put in a lot of effort in creating this nice pull request. We reviewed it even ourselves, so we would very much appreciate it if people actually first read the description. Because there's one thing that annoys me most, is the people that go straight past the description, start adding comments, asking questions that were already answered in the description before. And I also do the same, but then I usually go back to the description, and then I'm like Sheldon here, I figure out why they actually made a change. The other thing, make sure that you read the existing comments, because there may have been discussions already, and it doesn't make sense to re-repeat these discussions or have the same discussion in two different places. And then you start looking at it. And what you should be doing is you start from the top. And the reason why is because we are all tempted to go into the code, or most of us, or some of us, or at least me, and then I see and get distracted by the first code style issue that I spot. That's not the most important part of the pull request, because we first want to look at the whole feature. Because if we have feedback on the design, say we want the design to be different, then probably the code needs to be changed anyway. So we can start writing comments on code style, but if the code is not there to stay, then why waste our time on that first? First, get the bigger picture. Start with the design, then you go down and see if the functionality is in the right places. Does the functionality make sense? Is it not too complex? Are there algorithms, or did you cover all the scenarios? And then I added in bold, we start looking at tests. Because we often forget to look at tests. Tests are usually at the end of the pull request, because it's sorted alphabetically somewhere, and usually they're down there, and you just spend a lot of time going over the changes, you finally understand them, and now you get to the test part. And there's a lot of files and a lot of changes, and people sometimes tend to say, okay, the tests pass, sure, approve, fine. But this is where we should pay extra attention, because a bad test suite will in the end also affect us. If there's assertions missing, that means that there's openings for us to accidentally introduce new regressions. And these tests just don't get enough attention already during implementation, already during other reviews. So make a change here and start looking at your test suite and make sure that it also makes sense, that the assertions are done well. And then at the very end, only then, after we've looked at the tests, we can start bothering people about style documentation. So ideally, we want to automate that, and I'll get back to that part, the later part of the presentation. Now there's tools that can help us. like I already mentioned before, the version control systems. Tools like GitLab and I think also Azure DevOps or Bitbucket allow you to inline the code coverage of your in the diffs that you have in the browser. And I think that's an incredibly powerful feature because you immediately can see whether parts are covered or not. The alternative is to actually start looking at a code coverage report and then go over the changes, go over the code coverage report and go back and forth and see if it actually has been tested or actually go over the tests. I would say this is rather inefficient, and to be honest, I have actually not done that before, which is maybe kind of a bad thing. But if you add it in the diffs, it's there and it's really powerful. I find it really helpful. But there's other tools that also help. You can integrate Sonar, for example, that already starts adding commands to your pull requests. Even some tools like ArchUnit for a tool for mutation testing can add comments about mutants and everything. There's a lot of tools that can sort of enrich your pull requests with information, which is really powerful. But not all of us have access to or the ability to define these, decide on these features and what has been used. There's always one tool that everybody has, which is their editor. Why don't you do your reviews in your editor? Because say this change here, this is the change that we see in the diff. Doesn't look too weird. But if we now open it in our editor, we get more context. It's more easier to move around, but we'll also immediately see that, hey, something is now unused. Maybe this shouldn't be the case. Or, hey, there's some refactoring options. We can probably replace this with this empty. And that thing about code coverage, that's always there in your editor as well. So you can immediately see if you run the tests with coverage, like IntelliJ, and I think most editors support the ability to get the code coverage in your code, or in your editor. You immediately see, oh, this part hasn't been tested. Yeah, so please use your editor as well. It just makes it easier to move around, to get the context. Now, having looked at the code, we probably have found things that we'd like to see improved, that may have been wrong. And how do we address this? Because there's different ways to, to do this. So suppose here, the way people format, I need to get back. Yes, to writing a good comment. So you chose the wrong framework. Use X that is actively maintained. Now this sounds or can be interpreted as sort of an attack because it's you did it wrong. Whereas if you use terms like we is much more about collaboration, about doing it together. And even though we did not write this thing together, maybe you just did it by yourself, we all have the same goal, which is that we want to deliver nice software. So use the term we. Get used to using the term we whenever you could apply this instead of you, because people are more likely to collaborate. And the same thing with statements versus questions. So if I say you chose the wrong framework, that A, puts me at risk of being wrong, which means that I will probably look like an ass. But also, people might get defensive rather than collaborative again. And if you turn this into a question, you give people the answer to reply, which maybe they had very good reasons to do so. So a message like, why did we go for Y instead of it's wrong? And maybe you can add some subtext or some opinions that you might have, but make it open, give them the chance to respond. And this is much more friendly, which means that people are much more likely to cooperate and actually work with you. And they might actually, when you formulate it like this, come to the same conclusion. Ah, right, you're right, good point, rather than me having to admit my wrongdoings. Now there's another thing, the vague feedback. Try to always be specific. This, I don't like this, I don't like it. I don't like any references that might have multiple interpretations. So whenever you write comments, be as specific as it can be. And also, whenever you write comments, reread these and go over them if they actually make sense or if there are multiple things possible. And it's also very easy to say, I don't like the name, but try to come up with an alternative solution to what you do like, because saying no is it's a lot easier, but help the other person forward. And this actually goes further than just about comments. This is about any communication you actually effectively do with your teammates that is written. There's a lot of chance for if there's a lot of openings for miscommunication if you're being too vague. Try to be specific, because just like with code, write once, read 10 times, which also means if you invest a little bit more time in the messages you send, it's much easier and much more efficient. And the last bit that I want to mention here is that we should also make it a bit more positive. also try to find the good things. Because code reviews are usually not the most friendly place. You hear a lot of things that you could have done better, which you can either see as a learning thing, which I usually see it as a positive thing, but it also helps to also highlight the positive parts. Force yourself to find something positive. And this can be as simple as, oh, it's a feature that I didn't want to implement. I'm very happy that you implemented this. Maybe not in that exact formulation, but, or you learned something new. Maybe you didn't know about this API. It can be anything. Somebody put the effort to finally write a really elaborate test for this. That's great. Thank them for that, because this also helps them. Like what you see nowadays, there's a lot of imposter syndrome. We all see other people that are doing better than us, which makes us a bit more insecure. And just these compliments help boost people's confidence to, or sort of also overcome this and make people a bit more confident. Now, having done the code review part, I want to also cover another thing that's usually often seen with code reviews, which is bike shedding. Also known as the law of triviality. And it's about, Parkinson dubbed it, I think, at some point. I'm not sure if it's the same one from the disease, I don't think so, but it's about the fact that we spend a lot of time discussing the most trivial parts. In this case, we spend a lot more time, there was a corporate committee that spent more time discussing the bike shed of the power plant than the actual power plant, because it's much easier to reason about simple things than it is about complicated things. For example, it's very easy to say that you didn't like the dot equals and you should use this empty. But all these small, tiny code style issues, they just add a lot of noise. We want to focus on the bigger picture, right? And if I start adding comments on the smaller things because they distract me, I'm not looking at the bigger picture. And also you have people that just tend to say, okay, I added 5 comments, I'm done, looks now like I reviewed this, great. So I want to go over a set of tools that can help us reduce this by automatically doing this. And this is the way how I saved about, say, 20–30% of the time spent reviewing by automating all those things away. And the first tool, so I don't have time to actually demo them, so I'm quickly going to mention them, and at the end there will also be a list of links. The first one I want to go over is error-prone. For those who don't know, it's a tool that, it's a static code analysis tool by Google that helps you catch programming mistakes and code style issues at compile time. And the nice thing is that it also suggests automated fixes. So when you introduce error-prone to your project, you can also patch all these suggestions it gives so that they're automatically compliant. And the nice thing is that Picnic, it's a company from the Netherlands, has created an extra set of rules, which also are usually quite a bit opinionated, but they help you in sort of keeping your code consistent. And to give you some examples, filtering a list. You can do the address is not null, or you can use objects not null. Both do the same thing. In the end, it doesn't matter, but just pick one so you don't have any discussions about it and then enforce that one. No discussions. The same about big decimal value of 0. Maybe you just want to go for big decimal at 0 and then nobody can complain about it. You don't have to complain about it because the compiler already warns you about it. And the nice thing, there's also, when I started introducing this, I came across some bugs. Like, when you use string.formatted, that's with %s, not with the curly braces. And with logging, it's the other way around. And it is able to capture these. Or one that I also came across, I don't know if somebody can quickly spot the bug here. Yes, so one of the things, there's a possible null pointer, but the bigger problem even is this doesn't do anything, because it's assert that, which means you need a dot is equal to at the end. And this is hard to spot. I also would have not seen it directly, because I see there's an equals and I see assert that, so probably might be right. But probably you want to do assert that, get equal, you want to add the is true, or even better would be to say assert that some_pojo.getID is equal to. So I find this really useful. And when you start using tools like error-prone, test the rules in your code base and choose the rules that match. There's a lot of rules in there, and pick the ones that match your team style best. Also, keep in mind that error-prone does things compile time, so you might run into issues if you do weird things with Lombok. Don't do weird things with Lombok, but if you do, like Superbuilder, know that they don't go along very well. Another one, Open Rewrite. So for those who don't know about Open Rewrite, please check out Open Rewrite. It's a tool that has a lot of recipes to do large-scale migrations. It's, for example, adopted by Spring, that if you want to do your Spring migrations from 2.8 to 3, or from 3 to 3.2, it can automatically do almost all of them. It's just a set of recipes with changes. When applied, it's super quickly. And the same you can do for Java upgrades. The reason why I'm telling this, usually when you do this, you do this sort of in a rolling style, especially the Java upgrades. Like you have this new switch statement. And IntelliJ is just one click on the button to replace the switch statement. But if you do it in a running style, you either add noise by your feature change by doing these Java upgrades in there as well, or you get people asking the annoying question, hey, you're touching this file, can you also please fix this? Do it all at once, no discussion. Another source of bike shedding, I think the biggest one, is about formatting. You should have add line breaks there, or this is not formatted. People have opinions about formatting for some reason, even though it's, I think, the least relevant part, because whenever you go to a new company, you're going to be annoyed by the fact that they have a different formatter. Then you move to the next company, and you'll be annoyed that it's going to be different from the previous one and the previous. You'll always be annoyed whenever it changes, because we're accustomed to a certain style. Now, the best way, in my opinion, is to have a formatter that is so opinionated that you cannot have any discussions about it, because it saves you a lot of time in discussing it, and you'll get used to it anyway, as long as, of course, the formatter makes some sense. And I think the best example that I've encountered so far for Java is Google Java format. There's almost, I think there's only one scenario where you can have a line break or not. The rest is always formatted the same way, which means you cannot have discussions about code style. Now, Google Java format doesn't format, for example, there's editor plugins, but to actually do it via the command line, you can use a tool like Spotless. The reason why I like Spotless, there's also Spotify Java format, which actually does just Google Java format. Spotless can do all these languages, and they also have a lot of offers on different formatters for these tools. So I particularly like it because usually our products are not just Java. There usually is some SQL migrations that might be in there. There might be JSON files. You might have a README. You might have some Python migration scripts, maybe even a front-end code in there. There's so many things that we can format and argue about the way they're formatted. That we can also, so many things that we can automate so that we don't have to be bothered about it. And in that same region, we also have check style, which is great for enforcing naming or, say, the ordering methods, or in case, like me, when I was joining this company, I mean, I was new. I couldn't convince the team to switch to Google Java format because it was just too much of a change. I couldn't convince them. But the best thing I could do is at least find a way to enforce whatever code style we have, which we did through check style. So saying about, okay, there should be so much, there should be a line break after each this, or there should be anything you can think of. And the nice thing, because we use, for example, the IntelliJ code style, and you can't really automate that from the CLI, unfortunately. But with check style, at least we can force developers to actually do the formatting, which helped, because otherwise, every time I opened a pull request, the first thing I did was check it out in my editor, select the changed files, run the formatter, get a list of files that were changed, paste it back in the pull request, hey, can you please format these files? Now, that's time wasted, which you can automate. Then there's also this cool tool called ArchUnit, which helps us to enforce architectural guidelines and also naming conventions, but in a different way. ArchUnit is also used in the basis for Spring Modulib. And what it does, it allows you to define rules on package access, for example. In this specific case, I can say, I have a layer called controllers, which is defined by this package. And anything in this package can only access the layer below. So controllers package, for example, or controller package may not be accessed by any layer because it's our outmost layer. It doesn't make sense if the database layer talks to the controller layer. Then there's also the same we can say for services. Services should not talk to controllers, but they should also only be accessed by controllers and the way down. And it's nice to have some rules there, but we can also add rules on, say, naming, interface names. Now, there's many ways we can deal with interface names. We can prefix it with an I, we can postfix it with interface, or we can always postfix the implementation with impl or any other way. And to be honest, to me, it doesn't matter. They're all the same as long as you just stick to it. So you pick one rule, you apply this to your code base, and there's no more room for discussion about it. And it's consistent, which I think is the most powerful here. The same for controllers. The cool thing that you can do is if it's annotated with some controller annotation for controllers, usually you have address controller in Spring, for example, then that should end with controllers so that we always know how to find our controllers. Not that one is named controller, the other name is endpoint, and the other is I don't know what cool name we can think of. Having things consistent means we also cannot have discussions, we're able to find it. Now the nice thing about Arch Unit is there's already a big set of predefined rules that helps us capture some common mistakes. When you start doing this, check these rules out, but also create sort of a separate module where you define all these rules, and then share this module with all other projects. And there's many ways to do this. One of the cool features is that you can also define a new standard and say from here on only everything that was there is allowed, but whenever you make a change to them, you should improve. Or whenever you add a new class, it should be improved. So suppose I have some GraphQL layers, which I don't like the naming, but I cannot just change the GraphQL file names because that might cause issues. I can say, okay, anything that we have right now is allowed, but from here on it should be done better. Now, when you start introducing the tools, so you may now come back to your office on Monday, you thought, oh, these tools are all really cool, let's all implement them. And then do one pull request, and from now on we have all these tools. That usually could work. But the problem is also that if whenever it breaks, people will be standing at your desk because it fails because of you. Try to start small and get the team involved. Whenever there's like error-prone, contains many rules. Create a pull request with all the example changes that it does so that people can go over and have the discussion there. Do you like this rule change? Do you like this rule? And maybe people don't like it for their reasons. Maybe you can or cannot agree with them, and then you disable it. But then it's sort of an effort, a team effort. And that creates the shared ownership again, which is really useful to get these tools in and get them accepted by the team and embraced by the team. Now it's also important to centralize the configuration, especially tools like Airpone and Checkstar are quite configuration heavy, which this is a large portion in your POM file. If you don't have an parent POM yet, this is a great opportunity to introduce a parent POM and centralize this configuration so that we all share the same configuration across teams, so that it's also easier to switch teams and we all do the same thing, or at least across repositories. Now, to conclude, it's important to write descriptive pull requests and also to review them yourself so that you spot the first set of issues and that it's much easier for the reviewer, because again, maybe three reviewers will spend time on reviewing it, but only one person spends time on writing it. Make sure it's easy for them. When you communicate, try to be as specific as you can, and also try to be friendly and find the positive things, because it's not just about finding improvements, it's also sometimes a challenge to find the nice things. Challenge yourself. And use these features like the code coverage and your editor to help you review. And then all these things you can bike shed about, automate them away so that you can focus on the most important things. Thank you.